Hello Internet, my name is Quinn and this is Blondihacks. I'm moving forward on the valve gear control system for the A3 locomotive this week. I'm going to make the lever that goes on the quadrant. And that might sound like a simple part, but there's actually quite a bit to it. There's a ratcheting mechanism and all kinds of cool stuff in there. So it's a lot of neat parts to make. Let's go. The lever in question goes here on the quadrant. It's technically called the reversing lever, but it does more than reverse. It controls all of the functions of the valve gear. The lever we're going to be building looks something like this. It's a lever arm with a hand grip operated pawl mechanism that allows you to lock it into a position. I feel like this style of lever must have a name because it's pretty much ubiquitous in old machinery, especially in railroad equipment and farm implements. You'll see it all over the place. Basically, the entire pre-hydraulic world ran on this style of lever, but I couldn't find a name for it, so if there is one, argue amongst yourselves down below. They exist because in the pre-hydraulics world, you needed a very long lever to give yourself mechanical advantage to, for example, raise and lower the bottoms on your plow, but then you also needed a way to hold that lever at a given position, so there'd be some sort of ratchet mechanism, and some clever person came up with this hand grip style for that, and it very quickly became the standard. Also, if you've ever operated such an implement, you know that hydraulics are a freaking miracle and have to be on the top 5 of human inventions of all time. This is Kozo's design for that style of lever for the A3. It's a little bit overscale, of course, because it has to be big enough for us to get our human-sized fingers in there, so it will look a little bit large on the locomotive, but it's also going to be kind of inside the cab anyway, so it's not all that visible, and it is neat looking and functional. I found this piece of scrap in the bin that is pretty close to the correct overall thickness, so I'll start with this. I do need to rip a thin strip off the side of it to get the approximate outer dimensions of the lever. Then I'll finish the 4 long sides of this to a dimension that's a little bit larger than the final piece, and you'll see why in a second. A great machine for this is going to be the shaper. I'm actually really enjoying using the shaper for this kind of task, like the basic squaring up of stock, that kind of thing. For basic surfacing, the shaper is just so fast to set up. It's much quicker than the mill. And of course it does cut slower, but it allows me to leave the mill set up for precision drilling and other types of jobs. So this is kind of where the shaper is settling into its niche in my shop. The drawings actually suggest making this lever in 2 pieces, the lever arm itself and then the hand grip at the top as a separate piece. But that hand grip would end up being very, very small, difficult to fixture, and difficult to attach. So I think it might actually be easier to make them as one piece, but that does require a little bit of a trick, as you'll see. So after squaring up this rectangular bar, I'm now going to put this in the forejaw and I'm going to turn the hand grip on the end of it. Now the reason this is tricky is because the largest diameter of the round part of the hand grip is actually larger than the short cross-section dimension of the lever arm. However, I think I can still do it as one piece. So what I've done to work around that is I've milled, or I guess shaped this bar to be the thickness of the diameter of the hand grip, and then I'm going to turn the hand grip on the end of it now, and you'll see how this works out in a second. So I dial this in on the forejaw. I do have a video on dialing in rectangular stock on the forejaw chuck if you're interested. Check out my lathe skills playlist. A little ichrometer check, and that looks like that's running true. And now I can turn down the end of this bar to the largest diameter of the hand grip feature itself. As you can see in the drawing, it's quite an intricate shape. It's a very classical kind of hand grip shape on the end of that, so I do want to try and create that. But I'll start by turning this down to the largest possible diameter of the entire shape, and then the organic shape part of it, I'll figure out how to do that while I'm turning this. It occurred to me that this kind of organic freeform shape is actually a really good job for the Tornado hand turning system. So I thought I would try setting that up and see what it looks like. But I immediately did not like this because it means working very close to the jaws on the chuck. The Tornado system is really kind of best suited for a collet chuck. It's kind of its design purpose. So where your fingers are not working close to something spinning and dangerous, and where you also have enough clearance underneath the chuck to get the Tornado's table under there. But when I saw how close my fingers would be to the chuck jaws, I immediately noped out of that setup. put the tool post back on and I'll freehand etch-a-sketch the shape. I roughed it in with a simple round nose turning tool, then I refined the shape a little bit with some filing, and then I did a bunch of sanding to finish it up, starting with 320 and working my way up to 600 grit. And honestly, that worked out really well. I'd never claimed to be an expert on a machine tool, but I have done enough turning in my short career in model engineering that I was fairly comfortable freehanding that with the old etch-a-sketch motions on the hand wheels. You do get a lot better at that kind of thing the more you do it, and I'm pretty pleased with how that came out. That's looking pretty nice. It looks pretty hand grippy. I did extra sanding to achieve a fine finish as well, not just for appearance, but because that is mild steel, and a very smooth finish will prevent corrosion. Now I take it over to the mill and I can set it up and I can thin down the rectangular bar to the final thickness of the lever arm. So now hopefully the method to my madness makes some sense here. By starting with the bar over thickness, I was able to hold it in the lathe, turn down the knob, and now thin it down. I wouldn't have been able to do this otherwise. Next, it needs some holes drilled, and they are weirdly referenced from the top of the curved part of the handle in the drawing, so I lined that up with the edge of my vice jaw and then did my edge finding on the vice jaw and then centered up on the other dimension. I mean, the positions of these holes aren't that critical relative to the handle, so that method was fine. The critical dimension is the distance between the holes because, of course, that sets the throw of the lever arm. Center drill noises, center drill noises, center drill noises, drill noises, drill noises, drill ream noises, ream noises, ream noises, ream noises. This uppermost hole is the pivot point for the hand grip squeezy bit that controls the ratcheting pawl. And then one more hole I want to do while the piece is still rectangular. On the edge, there's a tiny threaded hole, a 080 threaded hole that holds the spring that gives the spring action on the hand grip pawl mechanism. So this little guy is going to hold that spring in place, and I thought, well, I'm pretty clever. I'm going to drill this while it's still square and easy to hold on to, and this plan is thus flawless. Before taking it down, I always like to do a quick test thread with the bolt that's going to be going in to make sure I've got it tapped deep enough and so on. That's looking really good. That's quite satisfying. I don't have a steel screw here, so I'll be using that brass one, but that's fine. It'll actually look kind of nice, I think. All right, so next I'm going to lay out the tapered sides of the lever arm. It has kind of a diamond shape, and just for appearance, it just looks nice. And I decided I'll just lay that out and cut to my layout lines, which has kind of become my go-to method for these cosmetic tapers and angle cuts. It's just really not worth the effort to calculate the angles and set up angle blocks or tilting tables or whatever for these kinds of little decorative cuts. Now right here is where I realized my mistake. That threaded hole in the edge that holds the spring needs to be square to the tapered surface, not the square surface that currently exists. Yeah. Now, unfortunately, that hole is too deep. It's going to still be there after I taper the part, but the lever is symmetrical side to side across the long axis. So I thought, well, I'll just plug the bad hole, flip the lever over, re-drill the correct hole on the other side, and none's the wiser. If I had a 080 screw in steel, I'd probably just Loctite it in there, cut the head off, and call it a day, but I don't. So instead I'm going to drill out the threads just a scooch larger. It's a metric scooch. And then I'm going to make a pin that's going to be a close fit in there, and I'll Loctite that pin in place. I could also silver solder it in place, but that would create a bunch of cleanup work and a bunch of mess, and silver solder I don't think is necessary here. Some Loctite 680 and that'll never come out of there. Then I cut off the excess and then mill it flat. And now when I mill the taper feature in there, that repair will disappear. I can get away with just the Loctite and not needing to silver solder it here because I'm not re-drilling the new hole in the same area. The new hole is going to get drilled on the far side of the part. If I was re-drilling in the same area, Loctite would likely not work. You'd want to silver solder it in that case, but no problem. I milled all of the taper cuts, and then I can just flip that part over and drill the new one on the other side. And honestly, that repair is going to be inside the cab anyway, so honestly, I could have just left the hole and you would never be able to see it, but I would know about it. Then I used my end rounding fixture on the belt sander to round the end of that lever, make it look nice. Now to redo that threaded hole, it's again referenced in the drawing from the end of the curved handle. The lever arm is now thinner than the handle, so I can't use the vice jaw trick that I did last time. It has to be sticking out of the vise, so I used a square up against the end of the handle, do my edge finding on the square, and then move from there. Again, the dimension here is not that critical. If it was, I would have referenced it from a gauge pin in one of the other holes, something like that. But drill and tap that now, square to the tapered surface this time, as it's supposed to be, and that all went great until I flipped it over and noticed that my repair plug is now nowhere to be found. I had thought that these holes were shallow enough that they would not intersect inside the part. Turns out they did, so once that drill hit that Loctite, it knocked the pin out. And, so I then Loctited in another pin to the same hole, and this time just filed it flush with the new tapered surface. And once again, no one will be the wiser, that repair will be invisible. Here on Blondihacks, we fix it right because we fix it twice, and that's a Blondie fact. With the lever arm done, I can now move on to the hand grip, the actual pawl mechanism that goes around that handle. Once again, starting with a piece of scrap, and I'm going to square up a chunk of it over here on the shaper. I just can't seem to get enough of this machine. It's just so fun to use. I really like this thing. The milling machine is sort of like driving a modern car. It's fine, it gets you where you need to go, it's reliable, does everything you need. But the shaper is like driving a weird old British sports car. It never works quite right and it causes you a lot of trouble, but it's just so much fun. This little hand grip clamping thingamajig has quite a complex shape, so I'm going to lay that out here on the surface plate. There's an angle to the handle part of it, there's a taper on it, and then there's a hole that needs to be in the correct position relative to that to create kind of a clevis. So I drilled the hole and then laid out the edges of the clevis relative to that hole to make sure everything lines up correctly. And that looks good. That's my rough shape now. So then I took that over to the bandsaw and I rough cut that. You should be able to waka that waste block out of there. And I'm going to now mill to my layout lines to create the overall shape of this piece. You can see it's going in a lot of stages because it's a complicated shape. There's a lot of weird and tricky angles on this thing. Luckily, none of the angles are too critical. Really just the overall length of it and the position of that hole are the critical dimensions. The closer we get to final shape, though, the more difficult it gets because it's getting smaller and smaller and smaller, which I guess is a pretty good definition of machining. Like, I'm new here, okay? One last milling operation I can do is to create the clevis at the end by milling through the center of the sticky up part there. I didn't show you this, but that hole is actually half clearance and half threaded. So I did that by drilling all the way through tap drill, then drilling halfway through clearance drill, and then tapping the lower part of the hole. And now when I milled out the clevis, I ended up with threads on one side, clearance on the other. For the final shaping, I ended up just doing this by hand. The piece is so small, I looked at all of my various shaping and end rounding tools and mechanisms and fixtures that I have, and none of them were really a good fit, both figuratively and literally, so I ended up just doing all of the rest of the shaping on this piece by hand. Lots of needle filing, lots of safe edge files, all the tricks. The final piece has quite an organic shape and a lot of tapers and angles and curves, so good old filing. It's good practice to do this kind of thing the old-fashioned way. Still the best sometimes. That should be it for this. There's a little tab that sticks down at the front of the lever grip handle thing. You can see, and that's effectively the pawl that's going to hold the lever into the various positions. So that looks like that's going to work. Now it just needs the spring that goes in between those two to keep it outwards and latched effectively. Now the drawings suggest using phosphor bronze sheet stock for this. I wasn't able to source anything like that, but what I do have is a whole bunch of spring steel shim stock. So I feel like one of these pieces will surely do the trick for a little spring. I wasn't sure exactly what the thickness should be, so I'll probably have to experiment a little bit, but I started with an 1/8 thou piece that seemed like it might be about right. I laid out a rough shape on there and I center punched where the hole's going to be, a bit overzealously, and now I'm going to drill that hole. Now drilling spring steel is a little bit tricky. You have all of the challenges of drilling thin material, plus spring steel is hardened steel, so you have all of the challenges of drilling hardened material as well. Stefan Gottsvinter has an amazing video devoted entirely to different methods of drilling spring steel. If I can find it, I'll link to that below. And he recommends a couple of great methods, one involving carbide drills and another involving carbide ball nose end mills. Unfortunately, I don't have either of those tools in the size that I need. However, what I do have is a whole lot of high-speed steel drills in this size. So, because they come in packs of 10, and so I don't really care if I wreck one doing this, so I'm going to use this. I'm also going to use a trick I learned from Mark Presling for drilling very thin material, and that's that you take a little piece of cloth or rag and you put it between the drill and the material. And what that does is it keeps the drill flutes from grabbing the sides of the material and pulling it upward, which distorts the piece and ruins the hole. You're supposed to do this with some kind of cloth rather than a paper towel because the cloth won't get cut by the drill. However, this is blue Scott shop towels, and you may or may not know this, but Scott shop towels are not paper. They are actually polyester fibers, so this is effectively cloth, and it works just fine for this. The other trick I'm going to use is from Stefan again. He says to run the drill very, very slowly, even for a small size like this. With those two tricks combined, you can see that was perfect. No drama. It drilled a perfectly round hole, no distortion. That was just flawless. So thanks to those two gents for helping me do that. Now I can cut the dimensions of the spring around that hole. I'm going to rough cut it first with some aviation snips. This is probably not very good for them because, again, this is hardened steel, but, well, don't tell my friends at Northrop Grumman and I won't say anything either. For final shaping and to get rid of the snip marks, I use the bench grinder, just very, very lightly, and making sure the piece is only oriented vertically so it doesn't get distorted. And you don't want to do this too much because you don't want to overheat the steel and take the spring temper out of it. So just very gently, very carefully refining the shape of that, getting rid of the cutter marks, and there's my little spring. Little tiny leaf spring. And if you're wondering, the drill that I used for that was just fine. It didn't hurt it at all. So with that spring on there, I can get the little hand grip thingamajig on there. I wish I knew what the names for these parts were. So that threads on there with another screw, and let's see how that works. Kinda. The spring is a little bit on the weak side. It's hard to tell on video, but it does spring back, but it's not like confidence inspiring, if that makes sense. It feels like it might not always spring back all the way. It just feels like a little bit too loose or too light of a spring. So I made another one out of some 15 thou shim stock, and that definitely has the juicy spring force I wanted. The spring action here is very positive, very confidence inspiring. However, this material is a lot thicker and I'm not getting as much motion, range of motion now out of the pawl. You can see that the thickness of the spring limits how much you can retract the pawl. So I didn't like that either. I ended up with a middle ground. This is, I think, 12 thousandths, and third time was the charm. That looks great. Now I can make the pin that attaches the lever arm to the quadrant. Very basic turning operation out of a piece of scrap that I found in the bin. One of the really nice things about making a locomotive is you make a lot of really small parts, which means you get to use up all of your little scraps that you've been squirreling away for years, convinced that they were someday going to be useful. Well, you were right. Always give in to the hoarder instinct. No, don't encourage that behavior. Finally, we need a tiny little E-clip groove, which means I gotta bust out my microscopic 12 thou grooving tool that I ground for this project, and it's getting a lot of use. There's a lot of this size of E-clip on this machine. I'll deburr that with a triangular stone. I've learned that deburring those grooves is really important, otherwise the pins don't fit through the holes when you're done. A little burr gets pushed up by the grooving tool that you really can't even see or feel, but then the pin won't go through the hole, and it turns out that's why. So I've learned to stone those, and now let's test fit that pin. Interestingly, I have to squeeze the clamp in order to get the pin in, because of course the pawl is designed to be going into notches that aren't there yet. So the pawl is effectively fully retracted all the time now. It has to be held out of the way in order for the distance to be right to the pivot point. But once the notches are there, then the pawl will have somewhere to fall into, and it'll all make sense. So for now, it's permanently squeezed, but otherwise everything looks good. The motion on that is really satisfying, honestly. It feels really good. I spent more time than I care to admit just doing this. Don't judge me. With that bolted on to the footboard, you can see how the lever arm sticks down below. That will connect to the reach rod, which goes forward to a series of linkages that will ultimately control the valve gear. That was a lot of work for a small component, but It was important to spend some time on this because that's literally where your hands are going to be when driving this thing. My hand is going to be on that lever all the time. So I wanted it to feel nice, wanted it to look nice, and wanted it to work really well. Spent some extra time making sure all of that was true. We've got a little bit more work before this thing will be drivable. We got to make all the little linkages that connect forward to the valve gear, but that'll have to be next time. I am out of time this week. Thank you so much for watching. Thanks to my patrons for making all of this happen every single time. You all are the best, the finest of humans, and I'll see you next time.